Hi, hello everyone. Today we'll see the case study on rocket propellants. So in this case study, we'll see what are the types of propellants which are used to propel the rockets, and then we'll see what is the application of the propellants and its uses. We'll see one by one. First, we can classify the propellants into three major types. One is solid propellants, liquid propellant, and hybrid. In solid propellant, both fuel and oxidizer in solid form, so we can use that, we can directly burn out the fuel, so that is one kind of thing. And then second one is liquid propellant. In this liquid propellant we have two tanks. One is oxidizer tank, another one is fuel tank. We need two tanks to burn up the fuel. So further we can classify the liquid propellant into monopropellant and bipropellant. Mono is nothing but a single chemical compound. Bipropellant is more than two chemical compounds. So these are all the classification in liquid propellant. Hybrid propellant, it is nothing but by having the advantages of solid propellant as well as liquid propellant, we can combinedly utilize the advantage of these two. So from these two only the hybrid propellant is coming to picture. So it will give you more efficiency when compared to liquid propellant or solid propellant. Next, what are the liquid propellant which are available in the market? So I already told you that in liquid propellant we require two fuels. One is for oxidizer, another one is for fuel. So here we will show the properties of the liquid rocket propellants, like liquid oxygens, what are the density, molecular weight, melting point and boiling point. So we have listed another things. If you look into this table column, you came to know that what are the properties of different fuels. And then I have told you there should be combinations. If you change the combinations, it will change the impulse, that is power of the rocket, right? So listen, chlorophene trifluoride and ammonia as a fuel, we can have specific impulse around 240, but another one is fluorine and diborane, which will give 310. So you can able to see the specific impulse. So which will give you the maximum efficiency around fluorine. Oxidizer is fluorine, another one is hydrogen. So that will give you the maximum specific impulse. So these are all the very important one while choosing a fuel and oxidizer for rocket engines. So next one is chemical propulsion system, solid propellant. I already told you that solid propellant is nothing but both fuel and oxidizer in a single chemical compound which is in a solid form. We can use any solids, that is lower calorific value, to burn out in the rocket. But the only disadvantage is we can't able to control the direction as well as speed of the rocket, because once it is ignited, it is not controllable unless otherwise the fuel is completely burned out, right? The last one is hybrid propellant. In hybrid propellant, so we can utilize the advantages of both solid and liquid propellant. So that's why hybrid is coming to picture. So these are all the various application of solid propellants. So you can able to see the rocket name and then particular types, whether it is a single grain or multi-grain. So and then what are the principal ingredients which are used for preparing the solid propellants. So if you see that one, we can able to recognize how the solid propellants are prepared. So in liquid propellant, we came to know that there are two types, monopropellant and bipropellant. Say we know that mono is nothing but single chemical compound. So listen, here in propellant tank there is only one fuel, that is hydrogen. So it is single chemical only. By pumping this hydrogen, we have another gas, or nitrogen or helium, which is used to pressurize the hydrogen. Then only the propellant is coming from the tank to the combustion chamber. So that is the thing. First, the best example of monopropellant is nothing but hydrogen. We must know that. So these are all the monopropellant systems. So which will give you the different specific impulse. Say listen. So Monarch 1. Here the specific impulse is around 230 seconds. Specific impulse. Thrust 0.2 ellipse, right? So here propellant is hydrogen. We can know that we said that hydrogen is one kind of monopropellant. Say all the Monarch rocket engines, they are using propellant as a hydrogen, right? So there are different specific impulses there. So there it is ranging from 230 to 235, right? Next, bipropellant. So in bipropellant itself, it says that different in chemical compound. Both fuel and auxiliaries are having different chemical compound. So which means we need to provide two different tanks. One is for fuel, another one is for auxiliaries. We need two pumping system to pump out the fuel from the tank also. So here the example of bipropellant is, we can have a number of examples. Say listen, here kerosene, hydrogen, nitrogen tetroxide. Oxidizer, we can use oxygens as a oxidizer, one of the oxidizer. That is the bipropellant. Again, bipropellant thrusters. We have LARS 1B, 1C, 2B. Here also you can able to see the thrust value. The nominal thrust is very high when compared to mono. Bipropellant thrust value is very high. So it is ranging from 90 to 145. Again, the specific impulse value is also high. That is 300 to 325, right? So these things are noted while choosing the propellant as well as rocket, the destinations. These are all very important. So I hope you all came to know that how the propellants are classified and then usage of the propellant